Good morning, good afternoon. My name is Alka Halberg. I am part of the Cohesive Marketing team. I will be assisting the team today with the webinar as moderator. We will give it another 30 to 60 seconds to allow all the attendees to join us today. Great. I think we can start. Hi, everyone, and welcome to our webinar on Journey from Reactive to Proactive Maintenance, Increasing Reliability with the Right Tools and Work Processes, where we will give you an actionable roadmap and checkpoints to gain the momentum and step change needed to maximize reliability. In this webinar, you will learn why most businesses get stuck on the maintenance and reliability maturity curve and how to overcome it, a roadmap to make a change in the maintenance and reliability model, how to leverage mass for increased reliability and optimize return on investment from the tool, as well as what value improving maintenance and reliability maturity will bring to your organization. Before we start, I would just like to highlight some administrative tasks. Note that this webinar will be recorded and distributed post-webinar. All the attendees are currently set to listen-only mode, but feel free to post any questions or comments in the chat or question box. We will address these at the end of the webinar. Should you have any technical questions or problems, please log it with the GoToWebinar technical team in the form of a question mark or help section on the panel itself. Right, I will be handing over the host to the host in a bit, but let me do an introduction of our speakers and Cohesive quickly. First, we have Kevin Sutherland. He works with clients around asset and network performance. Then we have Patrick Connerty, a director of services for our clients at Cohesive. He's also a Maximo subject matter expert and CRL. And lastly, we have Daniel Grimaldo, a senior maintenance and reliability consultant at Cohesive. Working across all stages of the lifestyle, Cohesive helps owner-operators embed digital ways of working that drive operational efficiency and enhance asset performance. Cohesive draws on core tech solutions to support its clients. These solutions include Bentley's Infrastructure Cloud, iTwin, and IBM Maximo, for which Cohesive is the largest implementer. Without further ado, let's dive in and hand over to our first speaker for today, Kevin Sutherland.
Thanks, Ilka. I wanted to just start by talking a little bit about uh, the cohesive legacy and where we've kind of come from in our DNA, and not only, sorry, a little bit about our cohesive legacy and what's in our. Okay, I'm sorry, but that was turned off completely. I don't know why. Not only do we have a tremendous amount of experience in Maximo implementations around the globe, but we also our Institute of Asset Management attendees and members of the Society of Maintenance and Reliability Professionals group, including several CMRP, Certified Maintenance and Reliability Professionals, and part of the Reliability Web network as well, with several certified reliability leaders. And in addition to that, we've had folks sitting on the ISO 55,000 council, setting those standards and progressing those standards throughout industry. So it's just a quick moment of our legacy and what's woven into our DNA along with Maximo, because I believe this gives us a unique view on what it means first, for Maximo customers moving to the Maximo application suite, and secondly, how to obtain value from that suite in a way where it's focused now partially on asset performance management and reliability improvement. So just again, quickly, our experience and point of view comes from a heavy dose of Maximo experience asset performance management, reliability work processes, and advisory consulting. And that viewpoint or perspective is a little bit like this, that on the left of the screen are all the traditional type things that Maximo customers performed and did on a day-to-day basis. There is now Manage, which is formerly Maximo, mobility aspects, inventory aspects. But if we take a look at what the other elements included in the mass suite um, look like, and I guess feel like, and what they're made up of, heavily they're on the asset performance management or what we call reliability improvement element. Things like monitor, health, predict, taking a very close look at condition data, trying to understand condition super well so that we can make the best decisions we can to intervene on equipment, up to predict, pushing that notification of potential failure very far back in the equipment life cycle stage. Then there's the reliability analytics element with failure mode data helping us create better strategies. So holistically, we see this as a great opportunity moving to mass to take advantage of this entire element of the platform for reliability improvement, number one, and two, to displace other systems that our customers might be working with in the past where Maximo didn't have this functionality. Now it's all in one umbrella. And again, we see this as a tremendous opportunity to really improve our game in maintenance and reliability maturity. Um, if I tried to simplify heavily that that journey from proactive, or excuse me, reactive type maintenance into proactive and condition-based maintenance, moving towards predictive maintenance, moving towards predictive analytics, um, I'd like to use the PF curve. So bear with me if you've seen this before, because I just wanted to simplify the improvement elements and make a quick point. Of course, old definition of failure where we don't want to get is here. That's equipment not operating, potentially with secondary damage, difficulty in, to repair. Sometimes I think people have studies have shown 3 times more expensive to repair in this stage to a little bit better definition of failure, where this is the equipment condition, this is over time, and there's a certain function we need to maintain to be able to produce or generate what product or electricity out the door to meet customer demand. Technically, now in this new definition, if we bypass this, if we go below this required function, we may not be heart failure, breakdown, but we're not delivering what we're intending to for our stakeholders. Um, Reliability work in the last 50, 60 years has told us there is a point on this continuum, on this age, that failure does start. Some deterioration is starting. It's very maybe imperceivable at the time, and then there's a point where, due to predictive technologies like oil analysis, continuous monitoring, vibration analysis, motor circuitry analysis, we can really see the potential for that failure. And it's managing in between the P, the F is the science of reliability improvement at its simplest. And the two kind of keys here is if our customers and the folks we work with work in the strategic domain, I'll call it, and I'll talk more about that in a moment. If you work on strategies, what's the right inspections and condition monitoring to do at the right time, it's going to help detect that potential for failure. It's going to push that as far to the left as possible. What that means is it gives a lot more time to be able to consider and plan corrective maintenance before getting to functional failure. The second item or area is if we're looking closely at analytics of what condition data came in, inspection results, work order costs, problem cause remedy coding, we can actually eliminate a lot of the problems like bad parts from vendors, poor operational procedures, um, maybe other maintenance processes that aren't properly happening. And if we can eliminate those and understand condition much better, we can push that functionally failed point further to the right. So we can make better decisions on equipment asset lifecycle replacement elements. So again, if we break it into the simplest way possible, the ways we can improve, give us more time. let us know earlier that there's a problem so we can address it on our own time before it impacts us. And two, let's extend the asset life cycle of our equipment based on a clear and proper knowledge of condition. I'd like to propose that just for a bit of a discussion model, I like to call it a maintenance and reliability maturity model. This model is 0 through 5. And the general idea is that let's just think about this as the highest level competency or highest level consistent achievement within an organization. So at a 0, this is an organization who's in business, but primarily they're either unable to or just letting equipment fail and repairing it. Um, if we think back on the PF curve we just saw, those folks are living at that F mark, that far to the right. Costs are again quite a bit higher there than if we can handle things in a proactive way. Um, on number one, plan maintenance, and this is looking primarily at time-based plan maintenance. And the general idea that is, yeah, it is a bit of an evolution to move to this point. We can put a calendar time on maintenance and consistently execute those items. But the problem is, thinking back to that PF curve, we're living too far to the left. We're probably going in doing time-based overhauls and replacements of things that probably had good life left in them, but we didn't properly understand that life and we didn't properly understand condition. We were simply looking at time. Next kind of evolution here, condition-based maintenance. So the technologies that have come out in the last 30 years or so, again, oil analysis, vibration, motor circuitry, infrared thermography, acoustics, thickness monitoring, tons of tools and approaches that are out there, as well as our IoT monitoring to give us a firm understanding of the condition of equipment. But the idea here is, that in each of these, there's a bit of a continuum. You can be from a 2, maybe to a 2.9, because we find that customers are really getting good at this level when they can put all the condition about their equipment together in one spot and make fast, accurate decisions, and hopefully automate work order or service request creation directly into to manage. The third element here is I call it reliability strategy driven. That's when we're moving from pure condition to going back and taking a look at what are our most critical assets. Let's use a reliability thought process approach to building a better strategy that says here's the right time to inspect and the right things to inspect or the right things to monitor, based on actual failure modes. So it really evolves, number two, to putting more of a failure mode approach and a failure mode thought process on those critical assets. Number four, when we understand the failure modes and conditions, um, eventually there will be elements where we'll go in and repair. We'll always have a few breakdowns, but when we see deterioration early, we'll be able to have the opportunity to do a corrective repair that's planned. But hopefully, we're going to go in and all those events, whether they be breakdown or planned corrective, we're going to put a problem cause remedy code on those. Potentially, we're going to look at what downtime occurred based on those to be able to put together a great form of bad actors and eliminate those bad actors one after one, from the worst on down the list. And finally, I kind of call the cherry on top when we're able to consistently or competently leverage things like predict, statistical optimizations, simulations, etc. Um, this is where we're really at the pinnacle, and we're optimizing organizational financial performance, based on either real events that have happened in the past or real-time data. And just a quick note, I'm not saying here that someone at level 2 can't get a data scientist, get a laptop, and try to put together AI/ML models or algorithms and spot places and find some benefit. You absolutely can. But what I am saying is that those companies can't consistently, systematically institutionalize predict at this level without really understanding the failure modes we're trying to battle, and then the problems that are coming through the system. So again, it's a bit of a discussion model, and I'd like for you to think about for a moment in your organization where you where you actually sit on that model. And we have a poll question. So I'll go. Hi, Elka. If you're speaking, I think you might be on mute.
Yeah, no, the poll is launched. No
Okay.
worries. It's all good. Great. So I close the poll. Can you see the results, Kevin?
I cannot see the poll nor the results on my side.
I can read them out to you, Kevin. So we've got the majority of the people, if you can hear me, going through 2 for 50%, and then level 3 about 33%, and the remainder kind of in that 0 to 1 phase, if that helps.
Okay, excellent. Yeah, I mean that's very fair about what I expected. And a point I should probably make is that based on the complexity of your assets and the complexity of industries, it might be that getting to level 3 is perfectly fine. It may be that it's not, the juice isn't worth the squeeze to go to level 4 or 5. But in highly competitive industries, highly regulated, highly complex oil and gas, chemicals, heavy manufacturing. Definitely, there's typically millions to be gained by making a step change from a 2.5 to a 3.5 on that continuum. So so how we talked about the opportunity that the maximum application suite, along with reliability approaches, is providing. We talked about a model for where folks might be today and improvement levels, kind of at a high level. I'd like to talk about a little bit more deeply. Well, how do you do that? How do you begin to take a step? What's that journey look like? And this is just showing again. This is the Maximo we know and love element, um, or an enterprise asset management solution where we're looking at inventory and work management, procurement, um, and what we're doing on a day-to-day basis is our proactive condition-based monitoring, our IoT monitoring. So we're doing work orders and monitoring that are highly inspection oriented to get data, to get results, to get condition of our equipment. We're also fixing some things that have broken and proactively fixing some things that this information has told us. That, here we're yielding condition, events, and alarms. Here we're yielding failure dates, work order dates, downtime potentially, work order costs, and hopefully problem cause remedy. And then we're also on a day-to-day, there's the production or generation that what's happening in our environment. Here, this is what we're monitoring, these things occurring and going on. And it may be here that we're seeing opportunities for lost generation or lost production, as well as downtime. Simple idea is that this is a cycle. We identify work, we plan, schedule, execute work. Identify work, plan, schedule, execute. So the idea here is with good practices and good leadership and good training, we can get pretty fast at identifying, plan, scheduling, executing work. But do we really get better? So I like to call this kind of it's the efficiency, effectiveness element. And I would just pose to you that you can get pretty fast doing this process and some level of improvement. And if you think back to the maturity model a minute ago, what one point I didn't bring out is that the first 3 levels were highly maintenance process related. The, the final 3 were reliability process related. So So I would like to point out that there is an execution domain we just covered, but before that, so there's, and here there's, I'd call it two ways, two areas to improve, but it all fits into a continuous improvement work process. The first thing is there's a strategic domain, I'll call it for simplicity. Here we establish drivers, measures, goals, KPIs. What kind of improvement do we want to make? And we better darn sure make sure we put the baseline of where we are today. The worst thing is having great work, great success, but we never got a baseline of where we were the last 5 years, 3 years, 1 year. So we can't really prove the impact we've had. So it's huge to put these right drivers, baselines in place to monitor progress. Second, do we have the right taxonomy, hierarchy? Do we have the right asset types and classifications to be able to write a work order at the equipment, maybe the system level? We aren't going to be able to get better if we're only writing orders at a unit level or a large system or heaven forbid a region. We really can't count costs and analyze at that point. So with some level of competency here, everybody's got tens of thousands of assets. So where are we going to focus? Here's an asset criticality element telling us where the most critical equipment, and I kind of broke that down into high, medium, low, because after that, there's a strategy development. So here's where we get to stage three of that maturity model, where we're getting a reliability driven approach. And notice I have reliability centered maintenance on just the highest criticality items. I would typically reserve that to the top 5 to 10 most critical percent. Then FMEA, a failure modes and effects type approach, on more of a 20 to 30% after that. And then beyond that element, maybe just a simple PM optimization. For example, if we put this in mass terms, what does the reliability strategies element of mass tell us we should be doing versus what are we doing and when? So we can optimize and get ideas on potentially cutting tasks or right sizing frequencies. So again, this is a strategic domain, and the idea is that this hamster wheel of the day to day, that we run on, it's now being informed by the best possible strategies on your most important equipment. We're doing absolutely the right things at absolutely the right time. The other side, now that we're getting great condition-based maintenance data, probably we're already getting some before. Let's say we have better strategies. We really need to make sure those are consolidated in one point, as I mentioned before. All the readings, events, alarms. Let me put it into one place and have the best possible understanding of equipment health. Hopefully, maybe that is going to even involve simple calculations, first principle models or physics models, to tell us when equipment deterioration is happening. And notice that's going to inform and tell us when to go in and do a corrective work order. Here's where we're looking at those failure modes, seeing, um, I see the potential for failures occurring. Let me in my time plan a corrective item. Now, once we've done this process, and again have all this data from the day to day, hopefully we're able to event code, so problem, cause, remedy, on the work orders that ended up being addressing a failure mode. So again, if we're able to consistently, at least on the important assets, at least on the critical assets, enter a problem, cause, remedy code, we're getting a long way towards a great bad actor list. And just to make sure that's fully understood, if we look backwards for 12 months or 18 months, what were the top 10 things that ate our lunch? What were the top most expensive things? The top 10 failures? And unless it was just a one and an act of God, for example, the idea is go in and eliminate those, put a small team and assign them, and using one of these three approaches. And here I've listed it from the right to the left based on my opinion of complexity. So let's say we've got a bad actor. In my opinion, the simplest is to get a root cause analysis team together and eliminate that defect. Doesn't take a lot of know-how, and doesn't, it hopefully fairly quickly can get us to a root cause which we can assign to someone to take care of. Alternately, there's statistical analysis. So looking at real world historical data statistically and trying to improve, doing things like life cycle costing, Weibull analysis, programs of growth analysis, etc. And then again, my opinion, the most complex, which requires data science, 2 years of real-time data, and the events on that real-time data marked, is using predictive analytics. Again, that's a bit of that cherry on top, which is super, and it's great for very critical equipment, but we've got a lot of know-how. Finally, the ninth kind of element or work process is if we've taken the time to narrow our focus and sharpen it here, let's look at the results closely, or better yet, have the system, have MAS look at the results and tell us, are our strategies effective? Or should we go back and reevaluate because our number of failures or costs have been high recently? And last point here, it's Cohesive's contention that there is a portion of the maximum application suite that can address and help our customers make a reliability step change in every single one of these elements. And with that, I will turn over to Daniel.
Thanks, Kevin. Good morning, good afternoon, everyone. So, as Kevin mentioned already, there are multiple reliability strategies. He talked about using defining some for the most critical assets and some for the lower criticality assets. So every organization needs to find out what are their needs and define which strategy is suitable for their needs and their resources in each case. You can have mm, multiple strategies implemented in your organization depending on the criticality. At the end, with all the strategies, we are looking to achieve the same things, which are reducing downtime. We want to minimize the unplanned equipment failures, increasing the equipment lifespan, implementing the right maintenance strategy, the right maintenance tasks. Obviously, will increase the useful life or the of the assets. Cost savings, very important. The right preventive strategies reduce the unscheduled downtime. And as Kevin said, reactive work takes 3 times more than planned work. So emergencies are always way more expensive than the tasks that are properly planned and scheduled. Optimizing the spare parts inventory, we need to have the right parts in stock. Also, the safety, we need to have a well-maintained equipment to reduce risk of accidents, and that will lead to a safer working environment. Higher operational efficiency by reducing downtime and having smoother operations and higher productivity. And at the end, as Kevin already mentioned, we want to identify failure modes that allow us to know what has happened already on the organization or what is likely to happen, and make decisions considering the data we have already. So let's go to the next slide. So there is time for a poll here. I would like to know which reliability strategy have you implemented on your organization. If you have implemented several, please go with the one you implement on your more critical assets. Okay, 1 minute already. So, well, it seems the majority of the organizations that are present are working with PMO, which is pretty much a strategy which starts from the existing preventive maintenance, which is a very basic, is a good methodology for a lower criticality assets. But again, as Kevin said, is not wrong that you're doing the basics. You need to identify what are your industry, your organization needs. At the end, that's the most important. You don't need to go to the most expensive or more resources consuming strategies if your organization or your industry don't don't need you to be at that point. Let's continue, please, with the slides. Okay, so I'm going to bring some examples here of some real cases. The first one I want to speak about is an RCM analysis completed on a mine, an equal mine. It was done to the emergency generator. Um, this is a RCM is usually a strategy that is started from scratch. Um, it requires a lot of resources. A whole analysis team was there, like consultants, operators, and maintainers. And the to complete the whole analysis took 6 weeks. 6 weeks working full time, the whole analysis team. Um, and the end results, around 600 failure modes were determined, around 280 of those failure modes were addressed with scheduled tasks, and are around 300 with not a scheduled task. So that means like tasks that are to complete it just once. As Kevin said, there are processes to be improved, training operators, training maintainers, a lot of things that are not possible just to be addressed with a preventive action. So yeah, of those 300, around 100 and around 100 were spare parts to keep in stock. Uh, let's go, please, Kevin, to the next slide. And the second case I want to talk about is about an analysis done to a freshwater supply for a whole city. So in this case, an MTA or FMEA analysis was completed, again, from scratch. Uh, an analysis team, but this time it was a smaller team, just a couple of maintainers and a consultant on or facilitator, and it took only 1 week to get the analysis completed. So you can see there are differences between the resources needed and the time the outcomes will come. But again, you will see also the difference on the results. On this case, around 400 failure modes were determined. About 80 of those were to be addressed with scheduled tasks, 50 condition-based, 20 PM, and around 10 to be done by failure finding. So again, it's less time consuming. The resources are needed are less, but you don't get as many failure modes and as you can get with as with an RCM, for example. So I want to bring you these actions because I wanted to highlight that the actions themselves are not if are not properly implemented. So you need to make sure the resulting actions are properly implemented to see the results. In the generator case, around 600 actions just for one asset. This is one asset of a mine, but there are more than 10,000 assets on that mine. And for the freshwater supply, there were around 80 actions to be implemented. But these 80 actions have to be implemented on more than 4,000 pipelines, kilometers of pipelines, 3,000 hydrants, and around 10,000 valves. So there is no way this can be handled with the proper systems and the proper tools. So again, these actions themselves are worthless if not implemented. And to be implemented, you need to have the right tools. So you need to have the right strategies done on the right way, and also have the right tools and use them properly so you can succeed. Again, the actions themselves are just suggestions if you don't carry them out on the assets. So make sure you have the strategies, but also the tools to get them implemented. And that's all from me. So I pass it to you, Patrick, so you continue.
Absolutely. Thank you, Daniel. So far, Kevin's talked about maintenance maturity or capabilities, how to bring the three documented domains he's listed through a reliability journey. And Daniel showed us what the cohesive reliability team can produce through studies. I'm going to talk about what this can all look like if you build it through Maximo. And to do that, I want to start by introducing the reliability strategies from IBM. Last year, IBM released the reliability application, and this came in the form of a library with 58,000 failure modes, which integrates into a new application called reliability strategies. So this is going to be crucial to kind of some of the tools and solution that we're going to show you. But note that reliability strategies is just a standard add-on, and this is included in all base mass entitlement. So Cohesive has leveraged our extensive Maximo and reliability experience to build a solution where you can take the details within the reliability strategies and apply that within your mass deployment. So now I'm going to turn this over to show you what we've built. All right, Kevin, I'm going to steal the screen here in a second. And I believe you now are looking at our criticality application. Okay, starting with the focus on criticality, if we know which asset failures impact our business, then we can start to prioritize the maintenance and reduce the overall risk to the company. What we have is a custom application. Oh,
Sorry, Patrick, we're just seeing
yes.
you, not the demo
Oh,
screen.
interesting. Okay, let's try this again.
You are sharing, just not the demo screen. You're
Yeah.
sharing the.
Okay, we'll try that a different way.
Patrick, I was having success doing the entire screen instead of just the app. I don't know if there's some
Gotcha.
nuance there.
Sure. How's that coming?
Yeah,
Got it.
that's it. You have it on now.
Okay. Yeah. Sorry. So we're in the Cohesive's custom criticality assessment application, and what we want to do there in Kevin's diagram early on, right? And I'm sure a number of you have already started this process. Is define what are your most critical assets. What's providing the risk, the highest risk to the company, and to do this, we wanted to come up with a solution that improves overall line of sight, right? So if we look at the reliability program, the asset management and work maintenance and supply chain, how can we include that in one application? And this with reliability strategies and some relational tie-ins is how we see that working. So beginning with a workshop to define what the key drivers are for your business. Some common areas would be around safety, environmental, customer service, throughput, probability of failure. what we're able to do is set a value on each one of these, and this can be configured fully to what your business needs are. But looking at this example, we've got a value assigned, which will be an input for our overall calculation of risk and criticality, and then descriptions for the team to select those. As we build out the calculation within this application, we're able to document the time and place, who it was performed by, not just the lead, but the entire assessment team. And we've built in flexibility here within the definitions tab that allow us to populate those domain fields. Further, whether it's an asset or location that you're running the assessment against, once ready, you can run your calculations, and then that'll produce our calculated risk score, which is a sum here. I can show you the formula as we go through the demo. And then our criticality is a score of 1 through 9. I can apply these directly to the asset and or location record that this is tied to. And we can see here which records it's been deployed on and where it's being used and when it was performed. Okay. So now that we know which assets are most critical to the organization, we can start to look at building out a strategy. And within the assets application, I mentioned reliability strategies or asset module. I mentioned reliability strategies. This is where I have those 58,000 failure modes. And we start with a list of about 800 assets to begin with. So we can see here there's a wide variety to choose from. I'm going to go with a centrifugal pump. So I start with my pump asset, and then I further go into the asset type. And then this is where it comes to bear, right? We can see a number of different type of configurations. So how is this asset built will lead to different strategies overall. Once I click on that, I can see from left to right here, I'm provided with 128 failure modes for this configuration, and then 10 ways to rectify or mitigate that potential failure. Over on the right, my boundary talks about kind of what's included in the strategy or excluded when applicable here. So it gives me a definition of what I'm looking for. And one thing I want to note as we go through this, in the 9.0 release, what you now have the option to do is modify or create your own custom strategies within this, right? So if you see something here that's related to one of your assets and need to modify it, that's now an option out of the box. Coming into the failure modes, right, I've got a number of different options to select from, and I'm going to bring in the Kingsbury type. Breaking down further, I've got failure mechanisms. As I look at fatigue, there's 8 different influences on why that might have happened. And I'm going to look at a problem with my lubricant. So this is the failure mode, right? We start to see where it came from. So fatigue was up here. If there are any stressors, what's pushing that to happen? As Kevin mentioned, right, we've got the P to F, and how do we start to move that further to the right? So the big concern here, right, is this is limited warning period. So to me, this immediately becomes a candidate for monitor integration to say, how can we bring in that sensor data to help trigger an early alert or an analytics for the lubricant, right? To say we've got this third party that's integrating into Maximo, and we can bring that data in to show we've got something leaching in there. So within that, a standard repair time is being offered, and then what type of opportunities or how can you find that? Down here is essentially our mitigation activities, right? I'm going to, and showing you where they are related or sorted by effectiveness. I'm going to continue left to right and then just click the tab up here so I can see a further detail of what's going on. I'm able to modify this or sort it by duty cycle, as well as when to how severe the service is going to be. So if we talk further along that oil analysis, this is essentially my PM and job plan, right? So what are the descriptors? You have the option to copy these out to a clipboard and then build that into your PM program. What are some of the considerations you'll need for your job plan, and how long should it take? What should be your standard frequency? Okay, so I have a strategy, or I can build out a number of different strategies within this application. But what we wanted to do is keeping in with that line of sight, how do we attach that to an asset? And that's what I'm going to show you next. Off the bat, I'm searching for our demo pump here from the boiler room, right? We can see the criticality score and risk have already been applied, and we're also bringing in health to document that. So in this instance, and just depending on time, I'm trying to watch the clock here as well. We have reliability strategies, monitor, and health deployed. Coming into the asset application, what we can see is that read-only criticality and relative risk have been populated from our assessment application, right? So we want to keep that single source of truth. I've gone through the practice of defining which are my most critical assets and applying reliability strategies to that, but I need to understand which ones they are and how they're being leveraged. So over here, we've got a dialog box showing that relationship. So within this, right, we've got 7 meters and a number of strategies that are being implemented at different levels, right? An asset can fail in multiple ways, and I want to see what we're doing to document that. So focusing on inlet pressure, right? We've got our failure mode and our mitigation activity. I'm just going to quickly show you if I need to dig into that further and understand what that's telling me from reliability strategies. We've built in a link directly to that, right? So I can document what the functional failure was. Again, limited warning period. How long does that take to repair? What are my options for mitigation? Just coming back to my other tab here, right? I can see that functional testing was the path forward with this one. Okay. Within that, I obviously had to build a series of meters to define where those strategies will be deployed. Within this one, we talked about a monitor integration. So for my inlet pressure, what I've done here is set up a device within monitor pump 03, sorry. We'll reference that as we do a quick intro into monitor and what's been built there, right? But I can see I'm bringing in sensor data, but I'm also deploying operator rounds as part of my overall strategy for this asset to reduce maintenance and define how far out I can push the functional failure. Condition monitoring point here, 10039, will show in the next tab. And then again, how are we defining the related strategy to this specific meter that's been deployed? Additional configurations that are relevant here. I've got my PM for the actual inspection, right? And then 10039, which I just mentioned. This is my inlet pressure. So how do we set a point of failure when we want to, or a threshold, excuse me. So we've got our warnings, right? What are those limits? And then tying to the strategy, what are we issuing? What kind of work are we going to perform? Related to increasing the reliability of the asset. Excuse me. Okay. Let's see here, real quick. This is our criticality tab as well. So we talked about what kind of scoring we would define here. I'm going to start from the bottom up as our relative risk is a cumulative score here, right? So we talk about the sum of each of those values. Times the probability of failure, right? So risk is probability times consequence. And then within our criticality, right, defining what each of the thresholds are and then weighting those against what the overall solution would be. So we've defined what are our most important assets. How are we going to better maintain them? What is the work going to be executed against that? And then I'm going to show briefly just what some of that data looks like and how else you can support that overall maintenance. So real quick, we're going to go into our alerts within Monitor. I can see here, right, we showed that device pump 03 is my device number, and then we had a threshold exceed on March 17th. As an operator, I can come in and acknowledge these alerts as they come in. I can see when a service request has been issued, or I can issue a new one myself. High level, that's a quick touch base. I'm going to move quickly because I know we're at time and near questions. The last part of the solution here is our custom scoring. So new enhancements with 9.0, right? The system is now telling you where you can add additional sorts of information. I'm looking at my health scores lowest to highest here for our configured assets. So I want to start to look at the one with the highest risk score to me. So that's, again, my pump 003. We have low health on this, right? So I need to take action. What Cohesive has done here is we've built our custom criticality score. So this is different from the standard out of the box. And then we've added a remaining asset value. So I have heavily exceeded the annual maintenance planned and cost to repair or replace this. So we need to look at that pretty soon in our overall review. Additional notes here, the reliability strategies application, linking that back into it. And as you can see, right, we're able to kind of bring these scores throughout the application, not just base manage, but monitor and health, and sharing the data between that. All right. So that is the conclusion of my demo. If I can share this correctly here. All right. So you all should be seeing our.
Yeah, I got it.
Thank you much. Okay. We've talked today about increasing your overall reliability and better understanding the assets you've deployed and plan to deploy in the future. We're confident that the new mass application will help organizations like yourself make those step incremental changes and bring yourself along the reliability journey. Understandably, for Maximo users, the transition to mass comes with a number of questions, not just about reliability, but about infrastructure, being able to better use and leverage the applications that maybe aren't being deployed currently. And to support that, we've built a free mass evaluation. This provides an expert-led, actionable assessment for your current EAM or Maximo instance that produces a roadmap for a seamless transition to mass using data points that you can clearly see and leveraging existing functionality to improve your ROI when moving to mass. Along with this recording, you'll get a link to learn more about the evaluation. And now I will open it up for questions and turn it over to Alka.
Yeah, thank you, Patrick, and thank you all for that informative session. We have time for some questions from the chat box. Patrick, what version of Maximo did you just demonstrate in your demo?
Yeah, sure. It's that is 9.0.
And then also, can Maximo import data from Metasystem or a Metasys?
Yeah, absolutely. So flat files, right? If you want to do static files, that can consume those into monitor or manage, depending on what you have deployed or are looking to optimize. You can also bring in IoT or historian data into monitor.
Great. If there are no other questions, I don't see any in the chat box or the question box, then we can conclude our webinar. I want to again thank our speakers for joining us today, as well as you, our attendees, for listening. We have additional information available on our website in the form of blog posts, articles, case studies, and even brochures. If you want to really reach out and discuss your strategic path forward, please reach out. You can also reach out via our website. Then that is a wrap for today's webinar. Kevin, Patrick, and Daniel, thank you again, and I wish everyone a great day.
Thanks for joining.
Thanks, everyone. Thanks, everyone.
Thanks, everyone.